Ammonia reacts with aluminium chloride is shown by the following equation. So ammonia is NH3, aluminium chloride is AlCl3. Draw diagrams to illustrate the shapes of NH3 and of AlCl3 molecules. Well, nitrogen's in group 5 of the periodic table, so it's got 5 electrons around it. It's got 5 in its outer shell. So it's in group 5 electrons in the outer shell. 3 of those electrons will be bonded in bonded pairs with each of 3 hydrogens. So 3 are used in 3 bonding pairs and there's a lone pair left over. Now, if there were 4 bonding pairs, it'd be tetrahedral. However, if there's 4 bonding pairs, it's tetrahedral, but one of them is now a lone pair. So we still sort of draw that on, the lone pair, but we know we don't see it, so we only include these 3 when we describe the shape. So it's pyramidal, or trigonal pyramidal. So it's a trigonal pyramid because it's got a base of 3. It's a trigonal pyramid. Now, if it were tetrahedral, 4 bonding pairs, something like CH4, say for example, then the bond angle would be 109.5. But when you replace one of the bonding pairs with a lone pair, the bond angle 109.5 comes down by 2.5 degrees. So 109.5 subtract 2.5 is 107. If there was another bonding pair replaced, so if one of these NHs was replaced with another lone pair, 107 would come down to 104.5. 107 take away 2.5 when you replace a bonding pair with a lone pair, brings it down to 104.5. So that would be something like water, incidentally. Anyway, it's a trigonal pyramid with a lone pair, 3 bonding pairs, bond angle 107. What happens in AlCl3? Well, that's slightly easier in actual fact. You've got 3 bonding pairs because aluminium's in group 3, so 3 electrons in its outermost shell. 3 chlorines bond those 3 electrons. Now, if there's 2 bonding pairs or 3 bonding pairs, then it's planar. So it's planar and it's got a bond angle of 120, so it's trigonal planar. It's only when you get 4 bonding pairs, or when the number of lone pairs add up the number of bonding pairs, go above 3, so 1 lone pair add 3 bonding pairs, 1 add 3 equals 4, that it stops being planar. Up until then, if there's 2 bonding pairs or 3 bonding pairs, it stays as planar. Trigonal planar, bond angle 120. Name the type of bond formed between N and Al in this compound and explain how the bond is formed. Well, the reason that N can bond to something like Al is because it's got a pair of electrons. Al hasn't got any electrons, so Al can't put an electron into a covalent bond and nitrogen put an electron into a covalent bond because aluminium, AlCl3, hasn't got any electrons in its outer shell. It's just bonded its 3 electrons that it had in its outer shell to 3 Cl, so it's got none left. So if it's going to bond to the N is going to have to put this pair of electrons into the covalent bond. So rather than the Al put an electron in and the nitrogen put an electron in and form a covalent bond, they do form a covalent bond, but both electrons come from the N rather than one from the Al and one from the N. So if you get a covalent bond set up where both the electrons have come from one of the atoms rather than one electron coming from each of the atoms, that's called a dative bond or a covalent bond. So it's a dative or a covalent bond. They mean the same thing, they're just different words for the same thing. So coordinate bond or dative bond, both electrons come from the N. Explain how the value of Cl-Al-Cl bond changes. Well, suddenly you've got a 4th bond. So here you had 3 bonds. Now you've got a 4th bond. It's bonded to an N. It's bonded. This N has suddenly bonded. So now instead of 3 bonding pairs, you've got 4 bonding pairs. 4 bonding pairs changes. So the 4 bonding pairs, just like on something like 4 bonding pairs, it's larger than 3 bonding pairs, so it's not going to be planar. 4 bonding pairs is going to be something like tetrahedral. It's going to be tetrahedral like something like methane, CH4, 4 bonding pairs, and 4 bonding pairs have a bond angle of 109.5.